So the question is given, A, B, C, and D are vertices of a quadrilateral ABCD such that diagonal AC is perpendicular to the diagonal BD at T. The equation of line BTD is given by 2y plus x equals to 18, right? Now, an AB, it's equals to 15 units. So question number 1, it says determine the gradient of line AC. Line AC, fortunately enough, we are given both coordinates. Are we given both coordinates? No, we don't have the coordinates of C, right? But we can use the information that is given that BTD is perpendicular to what? To AC, right? That means the product of the two gradients will be equal to minus 1, right? So if we can calculate the gradient of BT, if we can check the gradient of BTD, then we'll know the gradient of AC. And the gradient of BTD is on this equation. So let's just write the equation in a standard form. This equation in a standard form will be y equals to minus half x plus 9, right? So that means the gradient is half. So the gradient of AC, since AC is perpendicular to what? To BTD, then the gradient of AC will then be equals to 2, right? 3.2, determine the equation of AC in the form y is equals to mx plus c. This is a straight line. The standard equation of a straight line is given. M is for what? The gradient. So we know the gradient of AC, which is 2. Then we are going to substitute where there is M, we put 2. And then we are left with the task to find the value of C, right? We can take 1 point from A or C, but we have A. So A is minus 5 for Y, minus 2 for X, plus C, right? Then our C will be equals to minus 5 plus, is it plus 4, right? Then it will be, C will be minus 1, right? So the equation looking for here will be y equals to 2x minus 1, right? Okay. The third one, they say if the equation of AC is y equals to 2x minus 1, meaning even if you have failed to get the equation correct on 3.2, but they are giving you the equation now, because you cannot be able to answer this question without knowing the equation of AC, right? Calculate the coordinates of T. Now, T, it's a point of intersection, is where BTD and AC intersect, right? A point of intersection, we can get it by equating both equations, right? So we are going to equate the equation of AC and the equation of BTD to find the coordinates of what? Of T, right? Which is half x plus 9, it's equal to 2x minus 1, right? I'm going to take everything that is x to one side and the numbers on the other side. I'm going to have 1 over 2x minus 2x. This is equal to minus 1 minus 9. Okay? Minus half minus 2, that will be minus half and minus 2, that will be, is it minus 3 over 2? Minus 5. Minus 5 over 2, right? Equal to minus 10. So if we divide by minus 5 over 2 or we multiply by 2 over minus 5, that will give us x equal to 4, right? Now the coordinate of T, we have x now, which is 4. Sishota ngabani, y. Now to get y, you just pick one equation that you think is easy for you, either this one or this one, and substitute to x to get the value of y. So y will be equals to 2 in bracket 4 minus 1, and that will be 7. Right. 3.4. 3.4, if ABCD is a kite with AB equals to BC. So they are qualifying this diagram to be a what? A kite. A kite, it means this side is equals to this one. So even this one is equals to 15 units. And then this line will also be equal to this one, right? So this is a kite. Now we are treating this diagram as a what? As a kite. Determine the coordinates of what? Of C. How do we determine the coordinates of C if this one is a kite? Then this point here, it's a midpoint for A, C, right? So we can use the midpoint to find what? C. We are going to calculate as if we are calculating the midpoint, but we already know what the midpoint. So the part for x will be equals to 4, and the other part for y will be equals to 7, right? Let's use a different color. We are going to have x for C plus x for A over 2. This will be equals to 4 in this case. This is an equation to find the value of the coordinate yabani, C for x, right? And then what about y? We are going to have yc plus ya divided by 2. This will be equal to 7. So let's substitute to these two. All right. We want the coordinate. The coordinates of t as we have found them is 4 and what? And 7, right? To find the coordinate of C, we are going to use the midpoint, which means the midpoint, the part for x will be equal to what? Will be equals to 4, right? And the part for y will be equals to 7. So we are going to have xc plus xa over 2 equals to 4. And we are going to have yc plus ya over 2 equals to 7. Then xc, it's x. Remember here we've got x and y for now, right? So x on c, it's x. X in A, it's minus 2 over 2 equals to 4, right? What about y for C? 7. It's y, right? And then y for A, it's minus 5 divided by 2 equals to 7, right? Then we solve for x here. 2 times 4 is 8. You take the 2 to the other side, then it will be 10, right? 2 times 7 is 14. You take the 5 to the other side, it's 19. Because 5 will change the sign and even 2 will change the sign. So we've got 10 and 19. Those are the coordinates of C. 10 and 19. Okay? The next question, calculate the length of BT. BT. Now, we don't have the coordinates of B, right? But we still have an option here. If we take this triangle, this triangle is a right angle triangle, right? It has got a 90 degrees angle here. And then we know this side is 15 units, right? And we can find this side because we've got the coordinates of T and we've got the coordinates of of C, right? We can do this in our calculator. We can do this in our calculator quickly. Yeah, you don't need my calculator. Just punch yours. Right? 10. I have a problem now here. Okay, so we are determining the length of TC, right? It will be 10 minus 4, close bracket, squared, plus, open bracket, 19 minus 7, close bracket, squared. And the length will be 6 root 5, right? Now we can use the Pythagoras theorem to find the BT. Pythagoras theorem, we've got 15 squared equal to BT squared equal to, sorry, not equals to here. It's plus what? 6 square root of 5 squared, right? So to find the BT, we've got BT squared equals to 15 squared minus 6 root 5 squared. What is this? Punch everything. It's 45. So BT squared is equal to 45. The square root of 45, it's 3 root 5. So that's BT. Okay? And then the last question. Write down the length of the radius of the circle passing through point BCT. They are saying there's a circle that is passing through this point and this point and this point. So the circle is going this way, right? If we've got a circle like this one, a cycle like this one passing through BTC, right? Then this line is acting as a diameter because it subtends an angle of 90 degrees. Then if this one is a diameter, we can say, okay, BC, it's equals to 15 units. It's a what? It's a diameter, right? Okay, so if it's a diameter, therefore our radius is half of 15, which is 7.5.